Okay, so I had some questions on how to find the LCD. All right, so let's just do some examples of some problems where we just have to find the LCD. We're not going to do anything with it. We're not going to use it to do anything. We're just going to find it. All right, so in the first example here, suppose we had the fractions 3 over 10 and 5 over 6. So in a problem, you might be asked to add or subtract these or something like that, and that's what you'd use the LCD for. But suppose you just want to find it here. So what we do is we look at each one of the denominators. So let's look at this denominator 10. And what we're going to do is we're going to factor it. So let's break it down. 10 is the product of 2 and 5, right? Well, that's the factorization of 10. So I can just write that down over here. 10 equals 2 times 5. Okay, what about 6? 6 is the other denominator. I'm going to factor it down. 2 times 3. Right? Well, that's as far as it goes. So 6 is 2 times 3. So I've factored my denominators all the way as far as they go. And now what I'm going to do is I'm going to look for, I'm going to look at each factor, 2, 3, and 5. Those are the three factors. And I'm going to ask myself, what is the most times that number occurs in either of these? All right, so 2 occurs at most once here and once here. So at most it occurs once, and so the LCD is going to have 1, 2 in it. Okay, then I go to the number 3. All right, so how many times does 3 appear here? Well, it occurs once here, and how many times does it occur here? None. What's the most? 1. So we have 1, 3. Then I go to 5. How many times does 5 appear here? None. How many times does it appear here? Once. So I have 1, 5, so I include 1, 5. So my LCD is 1, 2, 1, 3, and 1, 5. I multiply them together, and I get 30. So my LCD for this problem is 30. Okay? So let's do another one. Let's look at the fraction 7 over 20 and negative 5 over 18. Okay, so here I'm looking for the LCD, the least common denominator, so I'm only interested in the denominators. So let's look at 20. Let's factor it down. 20 factors as 2 times 10. But that's not a complete factorization. I can factor it further, right? Because 10 has other factors other than 1. It has 2 and 5. But now I have a complete factorization. These numbers don't factor any further. You can write this as 2 times 1, but that's as far down as you go. You're just going to keep getting 2 times 1. So these are prime numbers. This is the prime factorization. 20 can be written as 2 times 2 times 5. That's what we found out here. Okay, let's do the same thing for 18. So over here I do 18, and I factor that one down. So 18 is 2 times 9, and 2 can't be factored in can't be reduced anymore, but 9 can. It can be written as 3 times 3, right? So my factorization of 18 is 2 times 3 times 3. So I'm going to write that over here. 18 is 2 times 3 times 3. So I see there are 3 factors appearing in here. There's 2, 3, and 5. So for my LCD, I'm going to write down, I'm going to look at each factor and write down the most number of times that it occurs in any one factorization. So let's start with 2. How many times does it occur here? Once. How many times does it occur here? Twice. So it occurs at most 2 times, so I'm going to write down 2 2's. Then I go to 3. How many times does 3 appear here? Twice. How many times does it appear here? None. What's the most number of times it appears? Twice. So I'm going to have 2 3's. Then I go to the 5. It appears none here and only once here. The most number of times it appears is once. So I get a 5 there. This is my LCD. I just got to multiply it out. Let's see, it's 4 times 9 times 5, and that comes to 180 if you work that out.